was over 3,700 public inputs and 1930 public comments to create the 2020 NEC. So when we think about changes, what's an important change? What's a significant change? It's really important when it affects what you do or the type of work that you're involved in. So something that's important to one person may not be important to somebody else because they're not doing that type of work or that type of occupancy. The other thing to keep in mind is the process that NFPA manages. NFPA is just a standards developing organization. They manage documents through what they call the open consensus process. And that's what allows them to have their documents ANSI accredited. By open consensus, that means that all the committees have balanced representation from various different interests in the industry. There's manufacturers, testing laboratories, inspectors, users, special experts in certain cases, and enforcers, and testing laboratories. Each panel can only have not more than any of those interest categories can occupy any more than 1/3 of the membership of a given panel or given committee. To make a change, you have to get 2/3 of the members to vote in the affirmative, whether you're adding something, taking something out, or modifying something. So it's much more than just a simple majority. And that's what's referred to as consensus. It doesn't mean that everybody on that particular panel or committee agreed with all the changes that have occurred. It just means at least 2/3 voted yes to accept that change. So we want to keep that in mind when we go through these. There are some things that even some of the panel members or committee members don't necessarily agree with that have become changes. One of the terms that was added is available fault current. And in the 2017 and many years prior to that, the NEC was very inconsistent on what it called things related to fault currents. Sometimes they called it short circuit current, sometimes they called it fault current, sometimes they called it a maximum fault current. They standardized on fault current, and that relates to what typically what you would get from the utility. If you're buying power from the utility, you'll contact them and they will provide you the maximum bolted fault current values. Then we use that along with interrupting ratings for overcurrent devices and short circuit current ratings for equipment to make sure all of our installations are properly installed. And we'll see a little bit more about that later on. Reconditioned equipment. Every code making panel, and we refer to them as CMPs, there's 18 of those, received public inputs to address reconditioned equipment. Can you recondition the equipment or cannot, or are you not allowed to recondition the equipment? And we'll see a nice table, it's in the analysis on page 86, that goes through and shows you the certain types of equipment that are allowed to be and ones that are not. For example, molded case circuit breakers are not allowed to be reconditioned.